And welcome to Joy Mathematics again. Let's continue our lesson videos on vectors. This time we are going to start with scalar product. Right, so what is scalar product? Scalar product is mostly known as dot product. Okay, so scalar product, it can also be called dot product. So it's called dot product because we have A dot B being multiplied together. So A dot B, in this case, we have a formula that A dot B is equals to the modulus of A multiplied by the modulus of B cos theta. Now, so if you say that, let's say A is a vector in this direction and B is a vector in this direction, we can have our angle theta. So let's take, for instance, that A is equals to A1I plus, let's say, A2I, A2J plus A3K, and B is equals to B1I plus B2J plus B3K. Now I want to evaluate scalar product. Now A dot B, in this case, will just be A being multiplied by B. So we'll have A, which is A1I plus A2J plus A3K, and B as B1I plus B2J plus B3K. And when we multiply this out, that means each component is going to multiply the whole bracket out. So we'll have A1I is multiplying B1I plus B2J plus B3K. Then A2J is multiplying the same thing, B1I plus B2J plus B3K. And finally, A3K is multiplying B1I plus B2J plus B3K. So with this now, we can move on to evaluate. Oh, let us open the brackets completely. So opening the brackets completely, we will have A dot B, which is the scalar product or the dot product between A and B, to be equals to A1I, A1B1 multiplied by I dot I. Okay, and we will have A1B2 with I dot J plus A1B3 with I dot K, plus the next line now, A2B1 J dot I, and we'll have A2B2 J dot J plus A2B3 J dot K, and the last line we'll have A3B1 K dot I plus A3B2 K dot J plus A3B3 K dot K. Now what we are saying here is just I dot I dot J, I dot K, J dot I, J dot J, and J dot K, and it continues down to the K dot K. So let us simplify. What does that mean? So we know that A dot B has a formula for magnitude of A multiplied by the magnitude of B cos theta. So we are saying that if we have I dot I, we will have that the magnitude of I multiplied by the magnitude of I cos theta. Now the question is, what is the angle theta? Now we have I in the x direction, and we also have another I, let's use this, in the x direction. Now we can see that the angle between these two eye is 0 degrees. The magnitude of I, okay, I being a column vector of 1 0 0, the magnitude of I is equals to 1. So we are saying that if we substitute angle theta here to give us angle 0 degrees, and this will be 1 multiplied by 1 cos 0, this will be 1 multiplied by cos 0 is equals to 1, which is 1. So we can say that I dot I is equals to 1. Similarly, if you have J, okay, let's say we have J in the y direction, J, it is being multiplied again by J. J being multiplied by J. We will find out also that J dot J is equals to 1. And finally, if we have K in the Z direction, okay, and we also have another K represented on it, we will also find out that K dot K, okay, K dot K is equals to 1, because the angle here is 0 degrees. Likewise, the angle theta here is 0 degrees. The modulus of K is equals to 1. The modulus of J is also equals to 1. However, if we have I dot J, or we have J dot K, or any other contradicting terms, let's begin with I dot J. This is I, and this will be our J. The angle between them, angle theta, is equals to 90 degrees. Now I dot J will be the modulus of I multiplied by the modulus of J cos theta, and that will give us 1 multiplied by 1 multiplied by cos theta, which is 90 degrees. Cos 90 degrees is equals to 0. So this is equals to what? 0. So I dot J is equals to 0. Similarly, we have J, okay, J, and then we also have K. In the 3D space, this angle theta is equals to 90 degrees. So J dot J will be equals to J modulus of J multiplied by the modulus of K cos theta, and that will be 1 multiplied by 1 cos 90 degrees. Cos 90 degrees is equals to 0. This will result into 0. So now we have come to a conclusion, okay, that I dot I is equals to J dot J is equals to K plus K, which is equals to 1. And I dot J is equals to J dot K is also equals to K dot I, which is equals to J dot I is equals to what? 0. We can just remove this. Is equals to 0. So if we come back here now to AB, let's copy this or duplicate. We want to continue with our term A dot B. Now we know that I dot I is equals to 1. So we have A1 B1 multiplied by 1. I dot J, as we have seen here, is equals to 0. So we have A1 B2 multiplied by 0. We also have A1 B3. I dot K, they are different terms, okay, multiplied by 0 plus A2 B1. J dot I is similar to I dot J, which is also equals to 0 plus A2 B2. J dot J is equals to 1, and A2 B3, that's J dot K. So we have J dot K here, which is equals to what? 0. So we have A3 B1 0, A3 B2 0, and finally A3 B3. K dot K, which is equals to, it should be dots, sorry about that, which is equals to what? 1. Now simplifying this, turns to 0, nullifies to 0, 0. We also have 0 here and 0 here. So we can come to a conclusion that this will result into a1 b1 plus a2 b2 plus a3 b3. So this is a dot b. So now let's make a summary. I have a is equals to a1i plus a2j plus a3k, and likewise I have b to be b1i plus b2j plus b3k. Therefore, I know the formula for a dot b is equals to modulus of a modulus of b cos theta, and likewise I know that a dot b is equals to a1 b1 plus a2 b2 plus a3 b3. So with this now, we call this principle or this theorem scalar product. Now you will notice the word scalar, okay, scalar product, because this all results a dot b, okay, the answer to a dot b is a scalar quantity. So in our next lesson video, we will take examples on scalar product of two vectors.